Today we will be talking about integration using trig substitution. First of all, let's talk about what inverse substitution to use for which expression. So if you have the square root of a squared, which could be any number minus x squared, then you will use the inverse sub x is equal to a times sine theta. If you have the square root of x squared minus a squared in your integral, then you will use x is equal to a times secant theta. If you have the square root of a squared plus x squared, you will use x is equal to a times tan theta. Keep in mind that the expressions do not have to be a square root, but it can also be to any power. Let's see some examples to explain more. So we have the integral of 1 divided by the square root of 4 minus x squared. For this expression, we use x is equal to a times sine theta since we have a squared, which 2 to the power of 2 equal 4 minus x squared. So x will be equal to 2 times sine theta, and dx will be 2 cos theta d theta. Now we sub these into the integral, and we now have 1 divided by the square root of 4 minus 2 times sine theta squared times 2 cos theta. We expand the exponent, so we will have 4 times sine theta squared. We can factor out the 4 within the square root, so we can have 4 times 1 minus sine theta squared, which is an identity that equals cos theta squared. Now that we have all multiplication under the square root, and they are simple variables to take the square root of, we take the square root of 4, which is 2, and the square root of cos theta squared is just cos theta. Now we can see that 2 cos theta will cancel since they divided each other, and we will be left with the integral of 1 delta theta. The antiderivative of 1 is just theta, and we add the constant c in the end. But we are not done yet, because our final answer needs to have the variable x not theta. So we look at x is equal to 2 times sine theta. We isolate for theta by dividing both sides by 2. Then we take the inverse of sine, so we can arc sine x divided by 2. So the final answer is arc sine x over 2 plus c. Let's look at another example. We have the integral of the square root of x squared minus 1 divided by x. Looking at the numerator, we can see that the best fit expression is x is equal to a secant theta. A is equal to 1, so we will just have x equals secant theta, and dx equals to tan theta times secant theta times delta theta. We sub these back into the integral, and our integral becomes the square root of secant theta squared minus 1 divided by secant theta times tan theta secant theta. Secant theta squared minus 1 is a trig identity that equals to tan theta squared. So we will have the square root of tan squared times tan theta secant theta divided by secant theta. The secant theta cancels, and the square root cancels, and we are left with tan theta times tan theta, which is tan theta squared. Now we can use another integration technique like integration by parts to solve this integral. But an easier way is to use trig identities and convert tan theta squared to secant squared minus 1, because we know that the antiderivative of secant theta squared is tan theta, and the antiderivative of negative 1 is just negative theta, and we just add our constant c. The last part is changing back the variable to x instead of theta. So we looking at x is equal to secant theta. It's basically x over 1, and secant theta is found by putting the hypotenuse over adjacent, since it's the reciprocal of cos theta. Now theta will just be arc secant x, but for tan theta, we draw the triangle, put theta at any angle, and make sure that the hypotenuse is x, and the adjacent to the chosen angle is 1. And for the opposite or the remaining side, you put the expression of x from the integral. Now we look at theta and evaluate it at tan theta, which is opposite over adjacent. So the square root of x squared minus 1 over 1 minus arc secant x plus c. So the final answer will be the square root of x squared minus 1 minus arc secant x plus c. The next example is the integral of 1 over 1 plus x squared to the power of 3 over 2 from 1 to the square root of 3. Now this time we don't have a square root, but we still have the same expression except that it's to the power of 3 over 2, but we can still use trig substitution to solve this integral. So the expression we have to use for this integral is x is equal to a times tan theta. Since a is just 1, we will just have x is equal to tan theta. Dx will be secant theta squared times d theta. Since we have a definite integral with an interval, we will have to evaluate x at 1, so we make 1 equal to tan theta, and arc tan 1 is equal to pi over 4. When x is equal to the square root of 3, we have the arctan of square root of 3, which is equal to pi over 3. We have to do this since we will be working with theta in this integral. So to correctly evaluate the integral, we also have to adjust the interval in terms of theta. Now we sub everything into the integral, and we get the integral of 1 divided by 1 plus tan theta squared to the power of 3 over 2 times secant theta squared delta theta from pi over 4 to pi over 3. As we know, 1 plus tan theta squared is a trig identity that is equal to secant theta squared, and now we will make the denominator equal to secant theta squared times secant theta squared to the power of half. All we did was break up the exponent 3 over 2 into 1 and 1 over 2, because using exponent laws we know that exponents are added when they have the same base, and they are being multiplied. This makes secant theta squared cancel since it's being divided by itself, and secant theta squared to the power of half is basically just the square root of secant theta squared, or since it's also an exponent to the power of another exponent. We multiply them, we are just left with 1 over secant theta. Since secant theta is equal to 1 over cos theta, 1 divided 1 over cos theta will just give you the integral of cos theta, which is now very easy to integrate. And we get sine theta, but we still have to evaluate the integral from pi over 4 to pi over 3. Since we adjusted the interval in terms of theta, we don't have to put the integral back in terms of x since we are evaluating it as a number anyways. So we do sine pi over 3 minus sine pi over 4. And using the two special triangles, we know that sine pi over 3 is equal to the square root of 3 divided by 2, and sine pi over 4 is equal to 1 over the square root of 2. We rationalize the denominator by multiplying the top and bottom by the square root of 2, which gives us the square root of 2 over 2. And since we have the same denominator, we can simplify our answer to be the square root of 3 minus the square root of 2 over 2.